Hello everyone, welcome back. Here's vanAmsen. Today we are diving into LeetCode Daily Challenge number 239, Sliding Window Maximum. So, the problem. Alright, let's get started. Our task is to find the maximum value in each sliding window of size key. So, key, it moves from the beginning to the end of an array. So sounds like simple task, right? But the trick is to solve it efficiently. So let's look at example. So if we have this array, we can have sliding windows. So 1, 3, -1, then 3, -1, -3, -1, -3, 5. So it's always the three elements given key equals 3. And from every element, we pick the maximum one. So, for example, 3 here, also 3 here. Here we pick 5. So it's rolling window, and we always pick maximum element. So it's simple to understand. So I will be using Python for this, and the main reason is simplicity and the ability of some awesome libraries that can make our lives easier. So like the Deque from the collection. So now let's get into a coding. So if not num or key equals 0, so edge cases, return empty, and if key is 1, return num. And deque will be deque. And now we have a result and traverse or indices. So range len num, and while deque and deque 0 less than I minus key plus 1, deque will pop left. Okay, so what we are doing. So first we handle the edge cases, and if the array is empty or key is 0, we return empty list immediately. And then if key is 1, our window size is basically each element. So we return the array itself. And now the core of our solution, so the double-ended queue or deque. So this beauty allows us to efficiently maintain the maximum of the current sliding window. So for example, for each element, we perform a series of steps to maintain our deque. So first, if the front of the deque is outside the current window, we remove it. So second, if our current number is greater than the last in our deque, we pop from back. So while deque and num I num deque -1. So we comparing new number and deque popping it. So we are popping element from the back. So we always have our maximum element at the front. And deque append index and I greater than key -1, then result append num deque at 0. So finally, we add the current index to our deque, and if our window is fully formed, we add a maximum which is at the front of our deque. So it's always at the front to our result list. And let's walk through example. Test cases. So yeah, return result. So let's run it and verify if it's working. So yes, as you can see, all work perfectly. So now we can submit it for unseen test cases as well. So hopefully it will pass. Yes, so our implementation passed, and we beat 88% with respect to runtime, and also 80% with respect to memory, so it's really efficient. So yep, now you see how Deque efficiently track the maximum for each window, and that's the power of the right data structure for the right problem. So there you have it, the sliding window maximum problem solved using a Deque. And remember, challenges in coding are just stepping stone, so face them, learn them, and improve. So if you found this session helpful, don't forget to hit the like button and subscribe for more coding adventure. And for those interested in other programming languages, I have added solution in other languages like C++, Java, Rust, and much more in the description below. So keep practicing, happy coding, and see you next time.